Hello. 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 Okay. So thanks for joining this session. Whoever have joined here, I'm going to discuss about differentiation, some problems based on differentiation. So let's see them one by one. Okay. So here is the first problem. F of x equal to 4x power 5 minus 5x power 4. So how do you do this one? So we have f of x is equal to 4x power 5 minus 5x power 4. So basically we just have to understand how the function looks like. Here we can see that we can apply the power rule. So therefore f dash of x is going to be, it's 4 times of differentiation of x power 5 is 5x power 4 if you use the power rule, and 5 into differentiation of x power 4 is 4x power 3. So if we simplify this, we'll get 20x power 4 minus 20x cube. You can leave it like this, or you can factor out the 20 and write down like this. In fact, you can factor out 20x cube as well, because I have x cube in both terms. So this is going to be x minus 1. So this is the answer for this question. Okay. So let's move to the next one. Okay, here we have f of x equal to e power x into sin x. So what rule we can apply here? We can see that it's a product rule. We need to apply the product rule. Okay, let's just revisit the product rule. If you have y equal to product of two functions, let's say that it is u, v. We say u as one function. This is a function of x, and v is another function of x. Let's say we call this as g of x. So therefore y dash, that is the differentiation of y, is equal to y dash, and this is given by uv dash plus vu dash, where v dash is equal to differentiation of v with respect to x, and u dash is differentiation of u with respect to x. Okay, so this is the formula we have to utilize to whenever we have to differentiate product of two functions. You could remember this formula, or by intuition you don't want to remember this. I just wanted to do it as it is. Just take the one of the function. I'm going to do it here. Let's say we call the first the e power function, e power x, as the first one, and sin x as the second function. So first you take the first function, multiply with the differentiation of the second function. So differentiate sin x is cos x. Alright, so then you put plus. Now you take the second function, that is sin x, and differentiate with the first function, multiply with the differentiation of first function, which is going to be e power x. Okay, So this is how we can apply the rule. We don't have to remember as a rule. Just by knowing the method we can do it easily. So now you can factor the e power x. If I factor the e power x from both terms, I'll get sin x. I put the sin x in front. The second term I put it in front. So therefore this is the answer for this question. Alright, so let's move on to the next one. Okay, so here it is. It's given as f of x equal to 3x squared multiplied with x cubed plus 1 power 7. So again this is going to be a product rule. We have to apply the product rule here. Okay, so this time I'm going to take the first function. Let's say first function is, let it be 3x squared, and the second function is x cubed plus 1 power 7. So therefore f dash of x is equal to, take the first function and then differentiate with the second function, multiply with the differentiation of the second function. So if I do that, it will be 7 times of x cube plus 1, applying the power rule, power 6. And then it's not a simple function, it's again a composite function. So we have to differentiate the x cube plus 1. Differentiation of x cube plus 1 is 3x squared. Okay, so this we did. Now based on the power product rule, we have to take the second function x cube plus 1 power 7, multiply with the differentiation of the first function. That is, if you differentiate the 3x squared, we will get 2x. So the next step, we just have to simplify this. Okay, so let's see how we can simplify this. I have 3x squared. So this 3x squared and this 3x squared I can multiply and put it as 6x power 4. Okay, so this I can put it as 6x power 4. Okay, I have numbers 3 into 3 is 6, 6 into 7 is 42. So I can put this as 42. Multiplying the x's, I will get x power 4, and then I have this term x cube plus 1 power 6 plus, so therefore this the second term is going to be 6x multiplied with x cube plus 1 power 7. Okay, so I think we can still simplify this a little bit. So this is going to be, we can factor out the x cube plus 1 power 6 from both terms. So here also we have this, we can see that we have x cube plus 1 term as plus x cube plus 1 term. We have this, so we can factor out that. So doing so, we'll be getting, I can factor out the x cube plus 1 power 6. If I do that, I'll get 42 x power 9 plus the remaining is 6x multiplied with x cube plus 1. So this is going to be x cube plus 1 power 6 multiplied with, we just have to simplify it inside, whatever we have inside, plus this is going to be 6x power 4 plus 6x power 4 plus 6x. So this is the answer for this question. Okay, so basically we just have to apply the power rule again. Alright, okay, let's move to the next one. Okay, here we go. We see that f of x is equal to cos power 4x minus 2x squared. Okay, so it's a combination of both trigonometric function and algebraic function. Nevertheless, we don't see that we can apply the product rule. We just have to differentiate it normally. Okay, so therefore f dash of x equal to differentiation of cos power 4x. So here we have to apply the power rule and then we have to apply the chain rule as well. So applying the power rule, we get 4 times cos power 3x, and then differentiation of cos x is minus c sin x minus differentiation of 2x squared. The second term is 2x squared, so that's going to be 2 into differentiation of x squared is, applying the power rule, you'll get 2x. Okay, so this is going to be, we just have to multiply this. We can put it in a neat format. This is going to be minus 4 sin x cos cube x minus 4 sin x. Alright, so this is the answer for this question. Let's move to the next one. Okay, so by now you could have thought like we have to apply the quotient rule. Earlier we did product rule, so this is going to be a quotient rule. We have to apply the quotient rule here. Okay, so let's say we say f of x equal to, say we have some g of x, some function in the numerator and some function in the denominator, h of x divided by g of x divided by h of x. Or you could, if you want to make it simple, you can put it as u by v as well, whatever it is. So therefore this is going to be the differentiation of this whenever you have functions like g of x divided by h of x, then you have to apply the quotient rule. So as per according to the rule, we just have to take we have to start off with the denominator function, which is h of x here, multiply with the differentiation of the numerator function, and then you put a minus. Then now you take the numerator function, multiply with the differentiation of denominator function, all divided by the square of the denominator function. This rule is as simple as that. Okay, so let's start off here. Let's just try to apply this rule over here. F dash of x equal to, okay, I don't think I'll have space here. I'm going to do from here. Yeah, so let me put f dash of x. So this is going to be, first I have to take the denominator function. So denominator function is x, multiply with numerator function. So I'll just write down here. So denominator function, this is going to be x, and numerator function, this is going to be x squared minus 1. So first I take the denominator function, which is x, and multiply with the differentiation of denominator function, this one. So differentiation of x squared minus 1 is 2x minus, now you take the numerator function, that is x squared minus 1, and then multiply with the differentiation of denominator function, which is x. Differentiation of x is 1, all divided by square of the denominator function, which is equal to x squared. Okay, so we just have to simplify from here. So this is going to be 2x squared minus of x squared plus 1, all divided by x squared. So which is equal to, we get x squared plus 1 over x squared. So this is equivalent to x squared over x squared plus 1 over x squared. This is, you can simplify this as 1 plus 1 by x squared. Okay, so this is the answer for this question. X squared minus 1, differentiation of x squared minus 1 over x is equal to 1 plus 1 by x squared. Okay, now let's move on to the next question. Okay, so if you can see this involves a logarithm. Let's try to understand what are the different functions in this question. We see log function, we see algebraic function, and then we see exponential function. So the log function is natural logarithm, the algebraic function is x, the exponential function is e power 7x. Okay, now so what rule we can apply here? We need to apply the log differentiation of natural logarithm. So suppose this is the formula, or this is the rule. If f of x equal to natural logarithm of x, Okay, then f dash of x is simply 1 upon x, or 1 over x. However, we don't see it as a simple x here. It's again the argument that we have in natural logarithm is it's a composite function. So let's just call this as, so let's say, in other words, we say f of x is equal to natural logarithm in g of x. Let's call this composite function as g of x. So therefore differentiation of this type is going to be 1 over g of x multiplied by g dash of x. Okay, so it's as simple as this. Maybe you can call this as a chain rule. Okay, now let's start off doing this problem. I'm going to write over here. So this is going to be f of x is equal to ln of x e power 7x. Okay. Okay. So as far as the rule is concerned, f dash of x, the rule says like f dash of x is equal to 1 over g of x multiplied by g dash of x. So you can call g of x, or we are able to identify g of x is equal to x e power 7x. So therefore f dash of x is equal to 1 by x e power 7x and differentiation of g of x, that is g of x. So you have to basically find the differentiation of this one. So we can do it separately, or you can do it here itself. So let me do this separately. So g dash of x is equal to, again now we can see that we have to apply the product rule here because it's a product of two functions, algebraic and exponential. So we have to bring out the concept of a differentiation of product rule. So it's very simple. You take one function, the first function, multiply with the differentiation of the second one, which is going to be 7 e power x, and then I take the second function as it is, multiply with the differentiation of the first one. So if you simplify this, this is going to be, in fact I can take e power 7x common from these two terms, so therefore this is going to be e power 7x plus 1. So g dash of x is basically, we can substitute here e power 7x into 7x plus 1. So now we can see that we can cancel this e power 7x. We can cancel this e power 7x, and finally it's going to be, if we simplify, it's going to be 7x plus 1 divided by x. You can still simplify this. This is going to be 7x over x plus 1 over x. So this is going to be 7 plus 1 over x. So this is the answer for this question. Okay. Let's move to the next one. Okay. Here we have this function f of x equal to x e power x to the power pi. Okay. So now we have to identify what type of function here, and we should apply the appropriate rule here. Okay, maybe you can think of f of x is equal to x power pi, or we can say it is x power n. Okay, where n is some constant. So we just have to apply the basic power rule. So therefore f dash of x is equal to n x power n minus 1. So in the same way I have to differentiate this one. F dash of x is equal to, I take the pi, I put it in front and multiply with x e power x power minus 1, pi minus 1, and multiply with, since it's a composite function, differentiation of, then you have to multiply with the differentiation of x e power x. Okay, we'll do it in the next step. So this is going to be pi x e power x to the power of pi minus 1 multiplied by, here we have to apply the product rule. So if I apply the product rule, we will get x e power x plus e power x. So now the question of simplifying. Just have to simplify this. Let's try to simplify. Okay, I think we can factor out e power x from these two terms. So this will remain as it is. This is going to be pi x e power x power of pi minus 1 multiplied by e power x into x plus 1. So now, since I have e power x inside, I think I can combine these two. So let me see how to combine this one. Okay, this pi I keep it as it is, and this x plus 1 I put it as it is, and this is x raised to the power of pi minus 1. So this one I combine it like this. Okay, and this e power x is also raised to the power of pi minus 1. So therefore this is going to be e power pi x. We just have to multiply the power minus x, and we already have one more e power x. Okay, so now it's going to be, just have to combine these two terms. This will remain as it is. We can put this as pi x power pi minus 1 times of x plus 1, and we just have to add the powers here. So pi x minus x plus x will become this minus x, and plus x will get cancelled. So finally we will get e power pi x. Okay, so this is the answer for this question. So basically we just have to apply the power rule as well as the chain rule when you differentiate the x e power x. Okay, let's move to the next one. Okay, so here we have f of x equal to x cube multiplied by fifth root of 2 minus x. So maybe you can figure out that we have product of two functions. We can call the one of them as let's say we call g of x is equal to x cube, and h of x is going to be 2 minus x is a fifth root. So I don't want to write down in this place. It's better we can write down in the power form. So this is going to be 2 minus x power 1 by 5. So now we can see this f of x is a product of these two functions, g of x and h of x. So we just have to apply the product rule here. So therefore f dash of x is equal to, take the first function, in this case the first function is g of x, so g of x equal to x cube, and then differentiate the second function, which is the h of x. If you differentiate this, we have to differentiate this 2 minus x power 1 by 5. So I'm going to apply the power rule, that is I put the power in front, 2 minus x power 1 by 5 minus 1, and then we just have to differentiate the 2 minus x as well. Differentiation of 2 minus x will give minus 1. Okay, now we go with the product rule, plus take the second function, which is 2 minus x power 1 by 5, differentiate the first one, that is 3x squared, that is the differentiation of x cube. Okay, so now we just have to simplify this. Okay, we can, okay, we have this denominator. Okay, so I can put this as minus 1 into x cube is minus x cube over 5, and this is 2 minus x. 1 by 5 minus 1 is minus 4 by 5, plus 2 minus x power 1 by 5 into 3x squared. Okay, so let's see if we can simplify this a little further. So we have x squared term as plus we have x squared term in both terms, and 2 minus x term also we have. So we can factor out the x squared term here. You could leave it in this form, which could be the answer for this question as well, or if you want to factor out the x squared term, then we will get, I'll get minus x by 5, 2 minus x power minus 4 by 5 plus 2 minus x power 1 by 5. Okay. Okay. Okay, or else you can continue to factor out the 2 minus x power 1 by 5 and give it in another form as well. That depends on how you actually proceed. Okay, so let's move to the next one. Okay, so we have f of x equal to cot of 6x. So this involves trigonometric functions. So you should be familiar with the differentiation formula for trig functions. If f of x equal to cot x, then f dash of x equal to minus cosecant squared x, right? Okay, one more thing that we have to look at here is we don't see it as a cot of x, we see it as cot 6x. So what can we do here? Okay, we just have to apply the chain rule here. Okay, so first let's differentiate the cot function, which is going to be minus cosecant squared. Instead of x we have to put 6x because we have 6x, and then differentiate the 6x. Differentiate of 6x is 6. So therefore the final answer to this question is minus 6 cosecant squared 6x. Alright, let's move to the next one. Okay, so this is another question involving trig function. Okay, so you can see that we can apply the product rule here. So I'm going to take the first one as secant squared x and the second function as tan x. So taking the first one and multiply with the differentiation of the second one, which is differentiation of tan x is secant squared x, plus take the second function and differentiate with the multiply with the differentiation of the first function, which is the differentiation of secant squared x. Differentiation secant squared x is we have to apply the power rule first. So it's going to be 2 secant x. If you apply the power rule to differentiate secant squared x, we will get 2 secant x, and then you have to differentiate the secant x. Differentiate of secant x is secant x tan x. Okay, now let's just try to simplify this. So the first part I am going to get secant power 4x, plus for the second part I have tan x into tan x is tan squared x. I have 2 in front, I put 2 and then 2 tan squared x. Secant x into secant x is secant squared x. Okay, this can be further simplified as by taking secant squared x common from these two terms. So the first term will be secant squared x plus 2 tan squared x. Okay, you can leave it in this form. This could be the final answer to this question. We have the identity 1 plus tan squared x is equal to secant squared x, right? So in place of secant squared x I can put 1 plus tan squared x. So this secant squared x I keep it as it is, and for this secant squared x I'm going to apply this identity. So this is going to be 1 plus tan squared x plus 2 tan squared x. Okay, so let's see if we can simplify this further. So this is going to be secant squared x. Okay, maybe we can put this as 1 plus tan x square. So the expansion of 1 plus tan x square is 1 squared is 1, tan squared is tan squared. No, we cannot put because it is 2 tan squared x. We cannot put. Okay, so we just have to leave it as it is. Or these two are the like terms, so we just have to put it as 1 plus tan squared x plus 2 tan squared x is 3 tan squared x. Okay, so this could be the answer for this question. Okay, the question is f of x equal to secant squared x tan x, and if you differentiate this, we'll end up with secant squared x multiplied by 1 plus 3 tan squared x. Now let's move on to the next one. Okay, so we got this one. Okay, so here we have y equal to 4 power 5 minus 6x. Okay, so what type of function we have here? See, for all the questions, basically we just have to identify what type of function it is. Accordingly, we have to apply the rule. So maybe we can see here it's a power x. We can apply this rule. So differentiation of this is y dash equal to a power x natural logarithm ln of a power x multiplied by ln of a. Okay, so let's do this one. If you have to differentiate this, y dash is equal to 4 power 5 minus 6x ln of 4, that is natural logarithm of 4, multiplied with, we just have to differentiate, we have to apply the chain rule, and differentiate the 5 minus 6x. Differentiation of 5 minus 6x is going to get me minus 6. So now upon simplification, no, we cannot simplify this further. We can leave it as it is, that is minus 6 into 4 power 5 minus 6x ln of 4. So this is the answer for this question. Okay, let's move to the next one. Okay, so here we have f of x equal to e power x into x squared plus 3 into x cubed plus 3. Okay, maybe you can think of, we can apply the product rule here. Okay, but usually we know how to differentiate if we have product of two functions, that is u dot v, or if f of x equal to g of x into h of x. So what can we do if we have product of three functions? It's nothing but we just have to apply the same rule here. We just have to extend the product rule here. Okay, let's just try to apply the extend the product rule here for three function, and then we will solve this problem. Let's say we have f of x equal to, let's say u v w. Okay, so then f dash of x, what I'm going to do is, for a moment I'm going to consider this as, let's say I say z. Okay, so then if I consider this as a z, so therefore f of x is equal to u times of z. Now I can apply the product rule considering this as two function, that is f dash of x is equal to u times z dash plus z times u dash, where your z is equal to v and w. So we know how to differentiate this one, so just have to substitute here. So upon substitution we will get u times, so z dash is going to be, again you have to apply the product rule for v, so it's going to be v w dash plus w dash v. So if we substitute for z dash in this f dash of x, we'll get v w dash plus w dash v multiplied by z times u dash. So finally it's going to be u v w dash plus u v w dash plus, okay, this is not correct here, this is v w dash plus, okay, so I'll just erase this whole part. So it's going to be v w dash plus w v dash. Okay, so if I substitute for z dash, I'm going to get u times v w dash plus w v dash plus z times u dash. So this is going to be u v w dash plus u v dash w plus u dash and z. Okay, this may look like intimidating, but nevertheless it's going to be easy only. If you do not want to apply the rule, let's try to do it in a different way. Okay, I'm going to copy this function here, f of x. So it's going to be f of x is equal to e power x into x squared plus 3, e power x into x squared plus 3, and then x cube plus 4, x cube plus 4. Okay, so what we do is, for a moment we can consider this as one function. Consider this product as a one function and this one as another function. So basically we are reducing the product of three functions as just product of two functions. So then we can apply the product rule. So therefore this is going to be f dash of x is equal to, I take the first one as it is, okay, that is e power x, and then differentiate the second one, that is I have to differentiate d by dx of x squared plus 3 multiplied with x cube plus 4. Then I take the second function as it is, that is x squared plus 3 into x cube plus 4 multiply with the differentiation of the first one, that is e power x. So this is all we have to do, even if it is product of three functions. So let's simplify this. This is going to be e power x into, now we can apply the product rule here. We just have to apply the product rule for this part. So I put a bracket here. So it's going to be, take the first one, that is x squared plus 3 multiply with the differentiation of x cube plus 4, that is 3x squared, plus take the second one, x cube plus 4 multiply with the differentiation of x squared plus 3, which is 2x. So this part is done. This differentiation of the second function is done. Now added with plus, okay, so there is nothing we could do here. We just have to write down as it is. So this could be written as e power x into x squared plus 3 and x cube plus 4. Okay, so let's see if we can simplify this further. We'll just distribute the e power x into this one. Before that, we just have to simplify what we have inside this bracket. So this is going to be e power x into 3x power 4 plus 9x squared plus, if I distribute the second one, I'll get 2x power 4 plus 8x. This will remain as it is, e power x into x squared plus 3 multiplied by x cube plus 4. Okay, so let's simplify this. Do we have like term here inside this bracket? Yes, we have a like term. So this is going to be e power x into 3x power 4 plus 2x power 4 is 5x power 4 plus, we don't have any other like terms, so we just write the other terms as it is, plus e power x into x squared plus 3 into x squared plus 4. Okay, now I can factor out the e power x from these two terms. So doing so, I'll get, so this is going to be 5x power 4 plus 9x squared plus 8x plus the product of these two terms. I'm going to do the product of these two terms. So first I multiply by x squared I'm going to get x power 4 plus 4x squared plus 3x squared multiplying with 3, 3, 4, 12. So now let's simplify this further. E power x into 5x power 4 plus x power 4 is 6x power 4 plus 9x squared and 3x squared is 12x squared. 8x, we don't have, no, we have one more x squared term. Just left this one. 9x squared plus 4x squared is 13x squared plus 3x squared is 16x squared. So this is going to be 16x squared plus 8x. We have only one 8x, that is the x term, plus the constant term is 12. So this is the answer for this question. So you should understand that even if it is a product of three functions, we simply have to treat it as a product of two functions and start differentiating. Okay, it may look like you are doing some extra step, but nevertheless it's just an extension of the product rule. Alright, let's move to the next one. Okay, so this one involves again log function, but here it is a little bit different. Okay, so if f of x is equal to log x base a, then f dash of x is equal to 1 by x natural logarithm of a. So this is the formula that you have to use to differentiate this type of function, because we don't have a natural logarithm here. We have log to the base 5. So we can consider that as, in a generic way, we can consider this as log x to the base a. So the rule says if differentiation of this function is 1 by x natural logarithm of a. So we just have to extend this rule because we have a composite function here. So let me extend this rule first of all. So if it is f of x equal to log, instead of x I'm going to put it as g of x base a, then f dash of x is equal to, we have to apply the same rule here, that is 1 by x ln a, but we have to put 1 by g of x natural logarithm a and then multiply with g dash of x. So this is what we have to adopt to solve this problem. So therefore the f dash of x, okay, f dash of x will be 1 by g of x. 1 by, our g of x is, this is the g of x, 3x squared plus 4x. So I write down that 3x squared plus 4x multiplied with natural logarithm of a. A here is 5, so I put natural logarithm of 5 and then multiply with g dash of x. G dash of x is, g of x in our case is 3x squared plus 4x. Okay, so this is the, so this is our g of x. So if you have to differentiate this, we'll get differentiation of g of x in our case is 3x squared plus 4x. So differentiation of this is g dash of x is equal to 6x plus 4. So you can put it here, 6x plus 4. Okay, don't think we can simplify this further. So you can write down in this form 6x plus 4 divided by 3x squared plus 4x multiplied by natural logarithm of 5. So this is the answer for this question. Okay. Okay, we have one more. Okay. F of x equal to tan cos x. So it's again we have to apply the chain rule. So basically we have two functions, that is tan function as well as cos function. So first we have to differentiate the tan function because that is the outermost function. So therefore f dash of x equal to differentiation of tan function is secant squared x. So instead of x we have to put the cos. So it's going to be secant squared of cos x, and then differentiation of cos x. Differential of cos x is minus sin x. Okay, remember to put the brackets appropriately. So therefore this is going to be minus, I can put the sin x in front, multiplied by secant squared cos x. Make sure that you put the bracket for cos function because it's part of the secant function. If you write down without a bracket, then it's not correct. Okay, so this is the answer for this question. I hope you like this live session, and I believe that you have understood how to differentiate mixed kind of functions. Like we understood how to differentiate if you have been given the functions with power rule, product rule, and quotient rule, as well as some trigonometric functions and logarithmic functions with natural logarithm, as well as with log to the base of some constants. Thank you. I will see you in the next session. Until then, bye bye.